Hello everybody. In this lecture, I'm going to introduce the concept of potential energy. What is potential energy? To understand this in a better way, here I'm going to consider two bodies, body A and body B. Okay? Within this body, there are n number of particles, huge number of particles. And these particles, they will keep on interacting with each other. So if the particles are interacting with each other, the energy associated with this interaction, that is called internal potential energy. Instead of that, if the body A is interacting with another body B, because for example, if you take it as a particle of mass, the body of mass m, and this has a body of mass m2, according to Newton's universal law of gravitation, what happens? These two will attract each other. By virtue of this interaction, they possess some energy. That energy, I call it as external potential energy. So internal potential energy means within the body the particles are interacting. The energy associated with this interaction is called internal potential energy. Instead of that, if two bodies are interacting with each other, that energy we call it as external potential energy. Whatever it may be, in the nutshell, I can say potential energy as the energy due to interaction between two bodies, or energy another way also body can possess potential energy. Here I am taking a single object. Let me call it as an object of mass m. So this body also can possess energy. Of course, it is not interacting with any body, but this body is in the field produced by the gravitational force. So one method is by interaction between the particles, that I call it as internal potential energy, and another method is interaction between two bodies, that I call it as external potential energy. This external potential energy I can write for this particle, this body also, because this body is under the influence of the field produced by gravity. If I place this in electric field, it is under the influence of electric field. Like that, whenever there is an interaction between a body and another body, or a body and the field, in such a case we will define this term potential energy. In the nutshell, I can say this potential energy as the energy by virtue of configuration. By virtue of configuration means to bring these two particles to this configuration, or some external agent has to do some work. That work is stored in the form of energy, which we call it as the potential energy. So potential energy is the energy possessed by the system by virtue of its configuration, because to achieve that configuration, some external agent might have done some work, because of which I call it as potential energy. So this potential energy is the sum of internal potential energy plus some external potential energy. But as long as mechanics is concerned, we need not to worry about this internal potential energy. Mostly we will use this term in the case of gases. Am I right? Gases. So kinetic theory of gases, in thermodynamics we will be coming across with this internal potential energy. Mostly in mechanics we will be dealing with this external potential energy only. To understand it even more better way, now I am considering this case. Consider this as the surface on which a block of mass m is resting. Okay, now particularly I am talking here about gravitational potential energy. What is that? U suffix D, that is gravitational potential energy. What is gravitational potential energy? Because when the body is in the field produced by the gravity, okay, there is an interaction between the body and the gravitational field, because of which this system possesses some energy. Now what I am doing is, if I keep this object on this surface, okay, I'm trying to define gravitational potential energy. To move this object through a distance, let me call it as h, okay, to a distance h in vertically upward direction, I need to do some work. Without performing the work, this body cannot move upwards, because the gravity is pulling it downwards. So to move it upwards, I need to apply a force whose magnitude is equal to mg, because here I am not imparting any kinetic energy to the particle. Slowly I am moving it. So because of which at every instant the applied force magnitude is equal to gravitational force. So as I am moving it in upward direction, then work done by gravity in moving it upwards is given by minus mgh, which I discussed in our in my previous lecture. Okay, so work done by gravity is minus mgh. This work is stored when the body moved through a height h, that is to this configuration. So this work which is done by external agent, because gravity is doing negative work, so to overcome this gravitational force I need to apply force in upward direction. I should keep it over here. So for that purpose I need to expel some energy. That energy is stored in the form of potential energy, so which I call it as gravitational potential energy. So because of which I can write down this gravitational potential energy Ug as work done by this external agent. Gravitational potential energy is work done by external agent in moving the object in upward direction. So because of which, what is the work done by external agent? That is nothing but work done by gravity is minus mgh, but work done by external agents is how much? Mgh only. So this is what I am calling it as gravitational potential energy. This work is stored in the form of energy. Okay, now based on the value of h, this gravitational potential energy can be, it can be U suffix g, can be positive when, because it depends on the reference. If you take this as the reference line and if you calculate gravitational potential energy, as the body is lying above the reference line, when body lies above the reference line, gravitational potential energy is positive. So gravitational potential energy is positive if body lies above the reference line. If at all body lies, that means to define gravitational potential energy, first you should take a reference level, that is called datum level. So with respect to that reference only, you can say you can define the gravitational potential energy. So with respect to that reference, if the body lies above the reference level, then potential energy, gravitational potential energy is positive. What if the body lies on the reference level? Here h is equal to 0, because of which uz is equal to 0. When if body lies on a reference line. Okay, and third case is, why should I take my reference level over here? Why can't I take at somewhere over here which is at a height h? So with respect to this reference level, if you talk about the gravitational potential energy of this body which is lying on the surface, in this case gravitational potential energy Ug is equal to minus mgh, which is negative. So gravitational potential energy is negative when body lies below the reference line or datum level. Okay, so through this what we can conclude, you can't define absolute potential energy. Whenever you wanted to define potential energy, you need to take a reference line. With respect to that reference line only, you can define potential energy. If the body lies on the reference line, potential energy is 0. If the body lies above the reference line, potential energy is positive. If the body lies below the reference line, then the potential energy is negative. Okay, and in my previous lecture already I told you gravitational force is a conservative force. So here one more important feature that I would like to discuss is work done by this conservative force. Any conservative force can be written as negative of change in potential energy. This is one of the important feature of a conservative force. Work done by any conservative force, whether it is gravitational force or electrostatic force or spring force, anything that you consider, work done by any conservative force can be written as a negative of change in potential energy. That I am going to show you here. So when I lifted the block from ground level to a height h, work done by gravity is minus mgh. So therefore gravitational force is conservative force. Now I'm going to prove it that negative of change in potential energy is also minus mgh. For that purpose, what is the change in potential energy? Delta U. Delta U is uf minus ui. What is ui? Initial potential energy. When the body is lying on this reference line, initial potential energy is 0. What is the final potential energy? Uf. Uf is equal to what you can write? when it is raised through a height h from this reference level, potential energy is how much? mgh, because of which therefore change in potential energy delta U is equal to mgh only, and negative of change in potential energy is minus mgh, which is nothing but work done by gravity. Like this, any conservative, here I considered a simple case to make the things very easy and understandable to you, but any complicated case that you consider, work done by every conservative force can be written as negative of change in potential energy. Alternately, this change in potential energy term also you can write it as delta U, that is nothing but uf minus ui, you can write it as, okay, uf minus ui, you can write it as negative of work done by conservative, that you can write it as negative of summation over f bar dot dr bar between the limits initial configuration to final configuration. Okay, these are very important observations regarding potential energy. One more time I am summarizing it. Potential energy, first it depends on our datum line or reference line. With respect to a reference only we can define potential energy. If the body lies above the reference line, potential energy is positive. On the reference line it is 0. If below the reference line it is negative. And one more important thing that I would like to remind you is potential energy depends on the reference line, but this change in potential energy is independent of reference line. Change in potential energy is independent of reference line. For this purpose, I would like to consider this example. Here I calculated change in the potential energy by taking this as a reference line. Now in the second case, I am taking this line which is at a height h above this ground level. I am taking this as my reference level and I am calculating the change in potential energy in this second case. Okay. So with respect to this line, what is the initial potential energy? Because body is lying below the reference line at a height, at a depth h, because of which initial potential energy ui is, with respect to this reference line, is equal to how much? Minus mgh. And when body is moved to this height h, what is the final potential energy? uf is equal to 0. Therefore delta u is equal to, which is nothing but uf, that is 0 minus, okay, uf minus ui is how much? Minus mgh is equal to what you will be getting? mgh only. So change in the potential energy, whether you took this ground line as the reference line or whether you take this upper line as the reference line, in every case change in the potential energy is mgh only. That means the very important thing that you should remember is potential energy depends on the reference, but change in the potential energy is independent of this reference line or the datum line. Okay, and every conservative force can be written as negative of change in potential energy.